I have been with MongoDB for over 2.5 years as an employee, but long before that, I was building with MongoDB. And I had a use case, some security, some IoT logs that really needed a search index. Search functionality, autocomplete, fuzzy matching, really to enable people to access information without necessarily knowing a query language, just knowing English or Spanish or Portuguese. And now I'm going to talk to what is the App Store but a search engine? What is Amazon.com but a search engine? What is Netflix but a search engine? What is Google but a search engine? Right? The most powerful organizations, the most influential companies in the world are all powered by search. But how is search built into applications today? Any ideas? Silent disco, so I don't know if you hear me. There's typically, it's just a database query, you know? You don't have to think about another system. You don't have to think about another language, another driver. There's no syncing with external systems. That makes sense. But the cons outweigh that simplicity. It's not feature rich. You end up lacking the ability to do simple relevance tuning. You won't be able to maximize the opportunity of a search feature, and it's going to impact your transactional workload, the main reason why you have the database in the first place. You have a ton of B-tree indexes. I don't care what database it is. You're suffering from serious write amplification. The other option is to spin up another system. We call it the bolt-on search engine. You have your transactional data store, MongoDB for many of you. We've been ACID compliant for several years now. I know there's a misconception. But yeah, you have your transactional workload. And then you have your search index. And you expose it with either Solr or Elasticsearch. And so you get fuzzy matching, autocomplete, the language analysis, the rich search features that your users have come to expect. But now you got the sync pipeline. And it's like, who saw Elon walking the sync into Twitter? You don't want to deal with a sync. You don't want that sync walking into your office. But this is what happens. It's like there's a lot of developer friction. There's a lot of overhead. And I tell people, you can think about it like this. You have your noise-canceling headphones on now in disco mode. You're just sitting there working on a class. Somebody taps you on the shoulder. You had the universal, don't touch me, bother me right now, signal on with the headphones. But somebody needs help, so you turn around. You talk to them. I mean, it's as disruptive as me putting my back to you right now. You turn back around after 3 minutes, you don't know what you were working on. I don't even know what file I was in. If I'm not using Vim, is it insert mode? Like, I don't know what's going on. That's the sync pipeline, constantly switching between things that don't have anything to do with each other. Why? Why do we do this if there's a better way? Because we don't know any better. Simplifying that architecture has really been what Atlas Search has been about. Developer productivity. The subsystem, the real juice in Elasticsearch and Solr is Apache Lucene. Apache Lucene is on the Atlas nodes now. And so you have one driver, one API, one connection string, one cluster. It's that simple. You go to the same place for all your data needs, your document data store needs, rather, to be specific. I'm not telling anybody here I'm doing away with S3. That's not happening. This is transactions and searches. And it's not just about search engines. It's about shipping features 30 to 50% faster. Like this is an important number in these times. We have to move fast. And to de-risk our decisions, we can have something that does the undifferentiated work for us with Atlas Search. 30 to 50% faster, that's a quote from a customer. You get autocomplete, fuzzy matching, facets, synonyms. And we've built synonyms in a new, fangled, easier to manage way where you can have automatically generated synonyms. I mean, this is the future. What are our target use cases? Catalog, search, content search, and single view. So with single view, I have all these disparate data sources. I want to understand what's going on. It's not always a search box, though. Sometimes it's just a complex query where you need 8 fields in a single index, 15 fields in a single index. You want to dynamically filter on user-defined criteria ranging from 5 to 15 filters. You know you have this use case if you have a ton of sparse compound indexes and you're trying to get things not to be collection scans. Who's using Atlas Search? I know it's relatively new in the grand scheme of DBs, but Lucene is pretty mature and very robust. And we have some of the largest grocery retailers, stock exchanges, insurance providers, social media companies, many social media companies, delivery services. I mean, the whole gamut. Online music tuition sites, car manufacturers. These are not the use cases we're for. You know? I'm not going to stand up here and tell you all you can jerry-rig Atlas Search and charts and make it better than Kibana. That's just not true. I'm here to tell the truth. These are the companies using us, but not for these use cases. We are focused on application search, application developers, application insights, getting access to information. But where are we going? Please scan this. It's a one-question form. Single question form. I'm not going to ask y'all to do too much work. All right, I'm going to keep going, but fill out that form. Raise your hand if you didn't get a chance to scan it. Too late. The top priorities have never changed. We're still focused on relevance-based, relevance-centric applications where people are trying to find important things. This is where we're focused. The data is already in Atlas. Let's not tell you to bring a bunch of other data that's not in Atlas. The data is already in Atlas. Let's enable you to build relevance-focused, relevance-critical search applications. We need to be able to scale, but most importantly, and in the middle of the slide, is productivity. We want you to go faster than you could otherwise, because you're not dealing with that sync. You're You don't have a boss coming in with the sink. Here, you know, no sink pipeline. Previously, we've taken a sparse vector approach. Really, Lucene is a vector database. People are talking about vector databases. There's a ton of hype. It's always been one. Like where two fields can be expressed as a vector, right? You have juicy, you have sweet. Where in the corner here, in the bottom right, near the sweet word, you might see bananas because they don't have any juice. Now, like the opposite corner, for juicy, you might see prune. Actually, I don't know if that's true. I've never eaten a prune. And a lot of times they're dried. So if they start off juicy and are never sweet, yeah, prune. But if anybody has a better example, let me know. But we're going to a different type of search where it's not just like term-centric, field-centric, boost here, boost there. No, it's too complicated. If you look at this graph, you'll be able to see Jerry and Elaine. I don't know what you think about when you hear Jerry and Elaine, but I've superimposed a last name on this graph to try to give you I'm trying to plant the seeds in your minds for where we're going. Anybody see the last name, the surname I'm referring to? Anybody? What is it? Seinfeld, right. So Jerry and Elaine, Seinfeld is nearby, in between the two of them. There's relationship. This is a relationship between these three tokens in literature, right? Jerry and Elaine are a couple, and Seinfeld, I don't watch TV, but that's what I hear. And this is where we're going. And I mentioned that an upcoming release will have Atlas Search. I'm here to tell you all that you already have vector search in your clusters, if you have Atlas. Now, to get the documentation, know the syntax, you have to fill out the form, which I'm going to tell you how to do in just a moment. But it's deployed to everybody. We have dozens of customers loving it, doing really interesting things, moving beyond naive lexical matching, Boolean matching, exact matches, and even fuzzy matches. This is now about matching ideas. Like just a few days ago, I was blown away, like Thursday or Friday, someone showed me they were searching images with text, but they didn't actually store anything else about the document. They just were converting the text to vectors, and those query vectors would then go and evaluate similarity with the image vectors in the MongoDB collection and search index. We are laser focused on democratizing sophisticated workflows. I don't know if people here know about PyMongo Arrow and how easy it is to interface with arrow tables in Atlas. But you can anticipate like typically complex or even mundane for some people, or just not fun tasks like hyperparameter optimization. We will make that easier for you. We will enable you to be more productive. This is where we're going. And the folks in here that go on the journey with us are going to have a lot of success. Go to the Atlas free tier. You can go to the documentation or the demos, and you can just download, git clone, some of the examples. It's all out there. We got a ton of examples. And, there's professional services and training for those who want it. Now, before I wrap up here, I need to go to this, to the other slide here. Can you go to the other tab? Yeah, thank you. So fill in the blank. Refresh it. Just let me see. I got it. Command R. 131 responses. Look at that. Test, machine, Allen, complete, machine, Enigma, test, computing, complete. These are the ideas associated with Turing. We didn't have to index this. This is already indexed. We're trying to make Atlas Search bring Atlas Search to you to unlock the stochastic model of information retrieval that behaves more like our brains do. Thank you.
Thank you, Marcus. Very, very interesting, and it would be great to see what you guys leverage with Atlas Search and how we've made it easy for you to take advantage of all those features. But obviously, we'd like to open the audience up for questioning for Marcus now. I'm sure you've got lots of questions around that. So if you show me your hand, I'll run over to you. And if you put your headphones on, Marcus, you'll be able to hear the questions.
Tight. Over here.
Great talk, thank you. From a vision or a future perspective, when are indexes across multiple collections going to be supported? Because now we have an index per collection, and from an application, even from a programming perspective, it's kind of hard to connect everything together, while I do want to do one search over multiple collections.
So there are three ways to accomplish this. One way we've made it possible is you can now you can set up a materialized view where you sort of have a collection specifically modeled for search, and you bring in the relevant data from each of the different collections, the disparate collections. That's if you have a very serious workload from like queries per second, requests per second, and a high volume there. If you're higher on the right side, we offer this feature called union with. $union with allows you to collate results from multiple queries. So you can have a union with search pipelines, and each of them across a number of collections. You still need to create an index on each of those collections, but you can have a single query with union with. The materialized view will get you the single index. Then the third way to do this is you can, depending on your queries and your use case and how you're trying to query across multiple collections, you can use the $lookup functionality, which allows you, it's more like a join. But again, you still need multiple collections. It's difficult for us to to enable one index across multiple collections because they're logical separations, and we're watching the change stream. But I think I've given you a few options. Let me know afterwards if that's not sufficient, and we can talk about it.
Thanks, Marcus.
Thank you.
Anybody else with some questions? Show of hands. Thank you.
Hey, Marcus. There was some mention earlier around scaling analytic workloads separately. Is there anything planned for search to do something similar?
Yeah, so that's a great question. There are two plans. So for 99% of our customers that need independent scaling, 99% of our customers today, I think this goes to 80% in the future, but like 99% of our customers today that need asymmetric scaling, they can take advantage of the asymmetric analytic nodes in Atlas. We have this functionality in Atlas. You can route your search queries based on read preferences to these analytics nodes and have your analytics operations powered by search. Search can be useful for a host of analytics operations. You should check out count within the search stage and facet within the search stage very fast on a large volume of data. Now, and scaling those analytic nodes can be helpful there. Secondarily, and looking forward to the future, sometime next year, I don't want to make any promises, we will actually be unveiling the ability to spin up separate infrastructure for search nodes, completely separate. Now, the problem with that is for most people, it's not the right approach for a host of reasons, and I can get into them probably after this talk in the hallway. But right, for those users who are really thinking about, like, I need 15,000 nodes really quickly. We don't want to spin up 15,000 MongoDBs, just 15,000 MongoTs, and throw them away afterwards. That is probably not the use case you're looking for, but that's on the roadmap, and that's something that we're working toward, and happy to answer any questions about the independent scaling. It sounds really attractive to people, but in reality, it's probably not the best solution, and there's a lot of latency involved in that architecture. That exists for all people who have that sync pipeline and separate nodes. Go ahead, anyone? Any more questions? And if you want to sign up for that, you can just let me know. You can work with us on that. No more questions?
What's a MongoT?
Oh, MongoT. MongoT is the process, the Java process that manages this replication. It does some really interesting things to get data from MongoDB into Lucene, and it also manages the Lucene indexes and interfaces with Lucene.
I think you've wowed them all away. Oh, we've got one down there.
Okay, so if we have a complex aggregate pipeline query in our main Mongo database, and everything effectively is being synced across to a text index, can we effectively apply the same sort of style of query on the text index, or is the essence of aggregate pipeline queries non-existent in the Lucene scenario?
Yeah, it really depends on the details around that query. Like, a lot of queries that you can do on ordinary MongoDB indexes, you can do in MongoT as well. They have some different characteristics, some different behavior, right? Like, theoretically, so the way we represent vectors in MongoDB today in Atlas Search is we have a large array, let's call it 512 or 384 dimensions, n-dimension array, right? A bunch of doubles, 768 doubles in an array. Theoretically, you could calculate the Euclidean distance between two arrays using math operations in MongoDB, in the aggregation pipeline today. However, in the search index, we allow you to do it in a more efficient way, more optimized specifically for this use case. So, yeah, definitely. There's multiple ways to skin the cat. Just make sure you use a search index and not a text index, because when you create when you do db.collection.create index, and you have a text index, that we're talking about something that we don't use. We use Atlas Search, which is, you have to make an API call.
So in that scenario, can I continue to query my main core production Mongo database and only sort of effectively opt in on a particular text search with the Lucene side of things?
That's right.
And keep, so I don't have to effectively deal with converting my complicated Mongo query to cover the extra stuff on the text.
No, you can leave the Mongo query as is and just add new search queries, yeah. And remember, we support search queries, text queries, image queries, geo queries, multimodal, Sound, there's some people doing some interesting stuff with sound. Going to their office tomorrow. So.
Well, thank you very much, Marcus. I personally really enjoyed that talk. Certainly a very powerful feature of MongoDB Atlas, and it will be very interesting to see how that develops out in the future as well. So thank you very much, Marcus.